Effect of temperature, mostly process of adsorption is exothermic, and reverse process of desorption is endothermic. We have already seen that during the formation of basically your interaction, if there is attraction between the particles or the formation of bond is there, that process is always going to be what? It is going to be exothermic. So process of adsorption is exothermic, while the process of desorption is endothermic. According to Le-Chatelier's principle, with increase of temperature, desorption is favored. So that is why we have understood your physiosorption was done at the lower temperature. That's the reason. According to Le-Chatelier, we have understood that if your reaction is exothermic and you are again giving it heat, so reaction will prefer to go in that direction where the heat is less. So that is your desorption. Physical adsorption decreases continuously with the increase in temperature. So that graph I am going to show you, where X, what are your X and M? X your X is your mass of adsorbate, while small m represent your mass of adsorbent. Higher this particular ratio will be, higher will be your adsorption. Why? Because more is your mass of adsorbate, right, which is adsorbed, right? Obviously this is mass of adsorbate, adsorbed, and similarly mass of adsorbent, right? So higher is this particular ratio, higher is going to be your adsorption, right? More is the mass adsorbed and smaller is your weight of your adsorbent, higher will be your adsorption. That is, the capacity of the adsorbent to adsorb is very, very high, right? Because in a very small amount of adsorbent, it is adsorbing a whole lot of adsorbent. So that is your tendency for adsorption. And as you can see, it was experimentally seen that increase of temperature, as you can see, as the temperature is increasing from left to right, you can see that the curve is going downwards. It is having a negative slope. So more increase in temperature, lesser will be your extent of adsorption, right? So your X by M is also known as your extent of adsorption. This is also known as your extent of adsorption. This is in the case of physiosorption or your physical adsorption. Now let us see what happens in the case of chemisorption. With increase in temperature, chemisorption first increases initially, and further increase in temperature can cause desorption due to the breaking of the bonds. So how does this graph will look like? It will be a bell-shaped curve. So as you can see, let's look at the graph, and you can see this is first it is going at a highest temperature, right? It is reaching at this particular temperature where the extent of adsorption is the highest, right? First it increases, basically at this temperature, this is your activation energy which is required to make the bonds. Afterwards, if you are increasing the temperature, you can see the extent of adsorption is decreasing. So there is a difference in graph of physiosorption and chemisorption, right? The extent of adsorption of a gas per unit mass of adsorbent depends upon the pressure of gas as well. A graph between the amount of adsorption and the gas pressure keeping the temperature constant is known as your adsorption isotherm, right? So now we are going to understand how does the pressure affects the extent of adsorption keeping the temperature constant, right? You are going to keep the temperature constant and then you are going to change the pressure. So these kind of graphs are known as your adsorption isotherm. Process is adsorption, isotherm means that your temperature is going to be a constant. So let's see over here how does it looks like. Right, so this is how your adsorption looks like with pressure. As you can see, first it is increasing and then it is becoming constant. Can anyone tell me why this is happening? Why I am seeing this particular kind of graph? This is your adsorption isotherm. At any temperature, if I will look, the same graph is going to repeat itself. First, the extent of adsorption will be increasing with pressure, and after a certain pressure, it is going to be constant, right? So we are going to understand it. Why did this happen, right? There were many scientists who came in front and tried to explain the adsorption curve, your adsorption isotherm. They tried to understand, right? A graph, as you can see, this is your adsorption isotherm. Since adsorption is reversible process, these options always take place simultaneously. Right now, let us understand the very first person who tried to explain the adsorption isotherm. That was your Frendulich, and he named his experiment. He named his whatever he told about the adsorption. He named it as Frendulich adsorption isotherm. Now he is going to explain us how does your extent of adsorption is depending on the pressure, and why I am getting that particular graph, that it is first increasing and then becoming a constant.